Close your eyes. Let the noise of the world fade away. Let the sounds of the city, the traffic, and the demands of your day dissolve into nothingness. Imagine that you are lifting off from the earth, rising higher and higher. The blue sky fades into a deep, dark indigo, and then into black. You are floating now, weightless, drifting in the infinite ocean of the cosmos. Here, in the deep void between the stars, there is no wind, there is no sound. There is only the silence, a silence so profound, so absolute that it feels heavy. It wraps around you like a thick blanket. This is the natural state of the universe, cold, dark, and quiet. Look around you. In the distance, you see them, the stars. Billions upon billions of them, like dust motes dancing in a sunbeam, suspended in the darkness. To us, living our short lives on a small rock, the stars seem eternal. They seem like fixed points of light that have always been there and will always be there. We name them, we navigate by them, we make wishes upon them, but the stars are not peaceful, and they are certainly not eternal. Let us travel closer to one. Drift with me now. We are moving across light years of empty space. We pass through clouds of cold molecular gas, nursery rooms where new stars are sleeping, waiting to be born. And there, looming ahead of us, is a monster. It is a blue supergiant, a star so massive that it defies comprehension. If you place this star in the center of our solar system, it would not just swallow the Earth. It would swallow Mars. It would swallow the asteroid belt. Its surface would extend all the way to the orbit of Jupiter. It is a burning sphere of plasma, 20 times the mass of our sun and shining with the light of 100,000 full moons. Look at its surface. It is not solid ground. It is a chaotic, boiling ocean of fire. Great loops of plasma, twisted by invisible magnetic fields, arc high into the sky, towering millions of miles above the surface before crashing back down. The color is not yellow, not orange, but a blinding electric blue. This color tells us a secret. It tells us that this star is hot, incredibly hot. While our sun burns at a comfortable 5,000 degrees, this giant burns at 30,000 degrees. It is screaming its energy out into the universe. But listen closely to the silence. Underneath the roar of the fire, underneath the blinding light, there is a struggle. A secret war is being fought deep inside the heart of this giant. It is a war that has lasted for 10 million years, and it is a war that the star is destined to lose. You see, a star is a contradiction. It is a balancing act on a tightrope over an abyss. On one side, there is gravity. Gravity is the sculptor of the universe. It is the force that pulled the dust together to make this star in the first place. But gravity is greedy. It is never satisfied. Gravity wants only one thing. It wants to pull every single atom of this star inward. It wants to crush this giant sphere down, to squeeze it smaller and smaller and smaller. Gravity wants to collapse the star into a single point of darkness. For millions of years, the star has resisted. How? By fighting back with light. Deep in the core, buried under millions of miles of heavy gas, a nuclear engine is running. It is a fusion reactor of unimaginable power. It takes the simplest atoms in the universe, hydrogen, and smashes them together. Proton crashes into proton, and in that violent collision, a tiny piece of matter is destroyed and converted into pure energy. This energy explodes outward. It pushes against the crushing weight of gravity. It is a stalemate. Gravity pushes in. Energy pushes out. The star holds its shape. It breathes. It lives. This state is called hydrostatic equilibrium. It sounds technical, but it is simply the balance between life and death. As you float here, watching this magnificent blue giant, you are witnessing a tragedy in slow motion. Because the star is running out of ammunition, it has a limited supply of hydrogen. It is a fuel tank that cannot be refilled. And because this star is so huge, because it is so bright, it is burning through its fuel at a reckless pace. It is living fast, and it will die young. Our sun is a prudent spender. It burns its fuel slowly and will live for billions of years. But this giant is a spendthrift. It is burning the candle at both ends. It has been shining for only a few million years, a blink of an eye in cosmic time, and already the tank is running dry. Drift closer now. Feel the phantom heat on your skin. We are about to dive below the surface. We are about to enter the belly of the beast to witness the beginning of the end. The silence of space is left behind. Now we enter the roar of the inferno. The outer layers of the star are thin, like a mist of fire. As we descend, the density increases. The light becomes blindingly white. We are traveling thousands of miles every second, falling towards the center. The pressure builds. The temperature spikes. We pass through the convection zone where currents of hot plasma rise like boiling water, carrying heat from the depths. Deeper, deeper still, until we reach the core. Here, the density is like nothing on Earth. The gas is squeezed so tight that it behaves like a metal. The atoms are stripped bare, their electrons torn away, leaving naked nuclei to crash into each other in the dark. This is the engine room. And here, the engine is sputtering. Look at the fuel gauge. The hydrogen is almost gone. The fusion fires are flickering. The outward pressure is weakening. And outside, waiting patiently like a predator in the night, gravity senses the weakness. It begins to squeeze a little harder. The star shrinks, just a little. But this tiny shrinkage increases the heat. And in a desperate attempt to stay alive, the star does something dangerous. It begins to burn its own waste. To understand the monster, we must first look back to a time when it was nothing more than a ghost in the mathematics, a flaw in the equations. The year was 1915. The world was on fire. The First World War was raging across Europe, but amidst the mud and the chaos of the trenches, a German physicist and astronomer named Karl Schwarzschild was doing something extraordinary. He was calculating the shape of the universe. Just months earlier, Albert Einstein had published his theory of general relativity. It was a masterpiece of thought. It proposed that gravity was not a force, as Newton had believed, but a curvature. Einstein said that matter tells space how to curve, and space tells matter how to move. Imagine placing a bowling ball on a trampoline. The fabric curves around it. That is gravity. Einstein's equations were beautiful, but they were also incredibly complex. Most scientists believed they were impossible to solve exactly. But Schwarzschild, serving in the German army on the Russian front, managed to find a solution. He wrote a letter to Einstein from the battlefield, presenting his calculations. But hidden within his math was something terrifying, a dark secret that even Einstein refused to believe. Schwarzschild discovered that if you squeezed a certain amount of mass into a small enough space, the curvature of the universe would become infinite. The fabric of space-time would not just bend, it would tear. It would create a bottomless pit from which nothing could escape. He calculated the precise radius needed to create this catastrophe. Today, we call it the Schwarzschild radius. For the Sun, this radius is 3 kilometers. If you crushed our Sun down to the size of a small town, it would vanish from the universe and become a black hole. For the Earth, the radius is barely 9 millimeters. Crush the entire planet into the size of a marble, and you would rip a hole in reality. When Schwarzschild sent this to Einstein, the great genius was impressed by the math, but he rejected the physical reality. Einstein believed that nature would protect us from such monstrosities. He thought that surely some force would stop a star from collapsing that far. For decades, black holes were dismissed as a mathematical curiosity, a fiction, a mistake in the algebra. But the universe does not care about our beliefs. It does not care about our comfort. While scientists argued in lecture halls, the stars continued to die. Gravity continued to win. And in the 1960s, the evidence began to mount. We started seeing things in the sky that shouldn't be there. Stars orbiting nothing, vast jets of energy erupting from invisible points. We were forced to confront an uncomfortable possibility. The math was right. The monsters are real. Let us pause and visualize what Schwarzschild truly discovered, because the reality is far stranger than any science fiction movie. We often think of a black hole as a vacuum cleaner sucking things in. But this is wrong. A black hole is a waterfall of space. Imagine you're in a river, paddling a boat upstream. The current is flowing against you. As long as you paddle fast enough, you can stay in place, or even move forward. Now imagine the river is flowing towards a waterfall. As you get closer to the edge, the water moves faster. Eventually, the water moves faster than you can paddle. No matter how hard you try, you will be dragged backward over the edge. This is exactly what happens near a black hole. Space itself is flowing inward, like water down a drain. At a certain distance, space is flowing inward at the speed of light. Since nothing in the universe can travel faster than light, nothing can paddle upstream fast enough to escape. This boundary, where the flow of space reaches the speed of light, is the event horizon. But here is where the discovery leads to a paradox that keeps physicists awake at night. According to general relativity, once you cross that horizon, all paths lead to the center, to the singularity. At the singularity, density becomes infinite. The laws of physics break down. Time and space lose their meaning. It is a place where when becomes where. It is a place that should not exist. And yet we have found them. We didn't just find one or two, we found millions. In 2019, humanity did the impossible. We turned the Event Horizon Telescope towards the galaxy Messier 87, and we took a picture. We looked directly into the eye of the beast, and what we saw matched Schwarzschild's predictions from the trenches of World War I perfectly, a ring of fire surrounding a central shadow. But this discovery raised more questions than it answered. If black holes are real, where does the stuff that falls in go? Does it disappear from the universe? And if they are so common, is it possible that we are living inside one right now? The evidence suggests something far stranger than anyone predicted. As we began to look closer, we realized that black holes are not just destroyers. They might be the architects of the cosmos. But to understand why, we have to look at the evidence. We have to look at the invisible signatures they leave behind. The first clue came not from what we could see, but from what we could hear in the high-energy spectrum. In the constellation of Cygnus, the Swan, sitting 7,000 light-years away, there is a blue supergiant star called HDE 226868. To telescopes, it looked like a normal, healthy star. But when we looked closer, we noticed something strange. It was wobbling. It was being whipped around in a circle every 5.6 days. Something heavy was pulling on it. Something with the mass of 15 suns. But when we looked at the empty space next to it, there was nothing there. Furthermore, this empty space was screaming. Intense X-rays were blasting out from the void. Scientists realized they were witnessing a cosmic vampire in action. The invisible partner was stripping gas from the blue star. As the gas spiraled into the void, it was heated to millions of degrees, crying out in X-rays before vanishing forever. This object, Cygnus X1, became the first strong candidate, but a single vampire in the dark was just the beginning. We turned our gaze closer to home, to the center of our own Milky Way galaxy. For 20 years, astronomers tracked the movements of stars in the galactic core. They watched a specific star, named S2. This brave little star was dancing a dangerous tango. It was orbiting a dark patch of space at blistering speeds, reaching 11 million miles per hour. At the bottom of its orbit, it made a sharp hairpin turn around. Nothing. The laws of physics are clear. To swing a star around that fast, you need gravity. Immense gravity. By calculating the orbit of S2, we could weigh the invisible object in the center. The result was staggering. 4 million solar masses, 4 million suns, crushed into a region smaller than our solar system, sitting invisible in the dark. There is no other explanation in physics. It is a supermassive black hole. We gave it a name, Sagittarius A star. But seeing the effects of gravity was not enough. We wanted to touch it. We wanted to hear it. And on September 14, 2015, humanity unlocked a new sense. We stopped just watching the movie of the universe, and we turned on the sound. Far away, in a distant galaxy, 2 black holes had been circling each other for millions of years. They were locked in a death spiral. As they drew closer, they spun faster and faster, churning the fabric of space-time like a blender. Finally, they collided. In a fraction of a second, they merged into one larger black hole. This violent union did not release light. It released pure gravity. It sent shock waves rippling through the fabric of the universe like a stone thrown into a pond. These ripples, called gravitational waves, traveled outward at the speed of light. They passed through galaxies. They passed through stars. For 1.3 billion years, they traveled across the silence of the void. And then they washed over the Earth. We were waiting. The LIGO detectors in America, 2 massive tunnels built to measure the smallest vibrations, caught the signal. It wasn't a visual image. It was a chirp, a tiny rising tone that lasted less than a second. But that chirp changed everything. It proved that space itself can vibrate. It proved that black holes are real, physical objects that can crash and merge. We had found the vampire feeding in Cygnus. We had watched the stars dancing around the ghost in our own galaxy. And now we had heard the splash of 2 monsters merging in the dark ocean. The evidence was overwhelming. We could no longer deny their existence. But this represents just one piece of a much larger puzzle. Because as we studied these ripples, and as we looked deeper into the shadows, we began to notice something even more disturbing. These monsters are not just eating stars. They might be breaking the universe itself. But seeing them and hearing them was not enough to understand them. As we peeled back the layers of the mystery, we found that these monsters do not just consume matter, they consume reality itself. The most disturbing evidence comes not from looking at the black hole, but from looking at the clock. Einstein taught us that gravity is not just a force that pulls on objects. It pulls on time. The stronger the gravity, the slower time moves. On Earth, this effect is tiny. Your head ages nanoseconds faster than your feet because it is farther from the ground. But near a black hole, this effect becomes extreme. It fractures our intuitive understanding of now. If you were to watch a probe fall into a black hole from a safe distance, you would never see it cross the edge. As it approaches the event horizon, you would see it slow down. It would move slower and slower and slower. The light coming from it would stretch into deep red, then infrared, then radio waves, fading into silence. To you, the probe would simply freeze on the edge of eternity, a ghost trapped in a moment that never ends. But for the probe, the experience is radically different. It crosses the horizon in an instant. It does not feel time slowing down. Instead, if it looked back at the universe it left behind, it might see the external world speeding up. It might see eons of cosmic history flashing by in seconds. This is the first deep implication. Black holes sever the shared reality between the observer and the traveler. They create a boundary where one timeline splits into two contradictory truths. However, the strange behavior of time is just the beginning. The most baffling discovery has emerged only recently, thanks to the golden eye of the James Webb Space Telescope. We pointed this time machine back to the dawn of the universe, just a few 100 million years after the Big Bang. We expected to see baby galaxies, small, chaotic, and young. Instead, we found monsters. We found supermassive black holes, weighing billions of times the mass of the Sun, sitting comfortably in the infant universe. This should be impossible. According to our standard models of physics, a black hole grows slowly. It eats gas. It merges with others. It takes time, billions of years, to become a giant. Finding a billion solar mass black hole in the early universe is like walking into a nursery and finding a fully grown man sitting in a crib. This discovery challenges everything we thought we knew about how the universe began. There simply wasn't enough time for them to grow that big, that fast, unless they didn't grow, unless they were born that way. This leads us to a terrifying hypothesis called direct collapse. The idea that in the thick, hot fog of the early cosmos, entire clouds of pristine gas didn't bother forming stars first. They simply collapsed under their own weight, skipping the star stage entirely and birthing massive black holes directly out of the darkness. These ancient giants suggest that black holes are not just the graves of dead stars. They might be the seeds of the galaxies themselves. They might have been here before the stars. They might be the anchors around which the rest of the universe was built. The evidence extends beyond the destruction of matter into the realm of cosmic genesis. And this forces us to reconsider the very architecture of our reality. But the true horror of a black hole is not what it does to matter. It is what it does to information. This brings us to the deepest battle line in modern science. A war between the two great pillars of physics, general relativity, the theory of the very big, and quantum mechanics, the theory of the very small. To understand the stakes, we must accept a fundamental rule of the quantum world. The universe never forgets. In quantum mechanics, information is immortal. If you burn a book, the information in that book is not destroyed. It is scrambled. If you could collect every particle of ash, every photon of light, and every molecule of smoke, you could, in theory, reconstruct the book. The past is always retrievable from the present. For a long time, we thought black holes were simple vaults. We thought that if you threw a book into a black hole, the information was locked away safely inside the event horizon, hidden but not destroyed. But in 1974, a young physicist named Stephen Hawking changed everything. He combined the math of the quantum world with the math of black holes, and he found something shocking. Hawking discovered that black holes are not truly black. Due to strange quantum effects at the very edge of the horizon, they emit a faint glow of particles. This is now called Hawking radiation. This radiation means that black holes are losing energy. They are bleeding mass. Over unimaginable timescales, trillions upon trillions of years, they will shrink. They will get smaller and smaller, until finally, in a blinding flash of gamma rays, they will pop out of existence. They will evaporate completely. And here lies the paradox. Here is the nightmare. When the black hole disappears, what happens to the book you threw inside? According to Hawking's original calculations, the radiation that comes out is random. It carries no record of what fell in. So when the black hole dies, the information is erased. It is gone, deleted from the universe. This creates a catastrophe. If information can be destroyed, then quantum mechanics is wrong. If quantum mechanics is wrong, then our understanding of every atom in the universe is built on a lie. But if the information is not destroyed, then Einstein's theory of gravity must be wrong. The black hole forces us to choose. Either the past can be erased, or our understanding of gravity is an illusion. This forces us to reconsider fundamental assumptions about reality. Is the event horizon a firewall that burns everything to ash? Or is the black hole a complex hard drive storing the data of everything it eats on its surface, like a hologram? Some leading physicists now believe in the holographic principle, the idea that our entire three-dimensional reality might just be a projection of information stored on a distant two-dimensional surface. The monster has shown us that the universe might not be what it seems. It might be a hologram, and we might just be shadows dancing on the wall. If the information is not destroyed, and if it is not merely plastered on the surface like a sticker, then there is a third option, a possibility so staggering that it borders on madness, yet it sits comfortably within the equations of general relativity. Perhaps the black hole is not a dead end. Perhaps it is a door. In 1935, decades before we had even named these objects, Albert Einstein and his student Nathan Rosen were playing with the math of space-time curvature. They discovered that the singularity might not be a point where space ends, but a tunnel, a bridge connecting two disparate points in space and time. We call this the Einstein-Rosen bridge. You know it by a more popular name, a wormhole. If this hypothesis holds true, then falling into a black hole would not be a journey into nothingness. It would be a violent transit. You would fall through the throat of the monster, passing through a tunnel where the walls are made of warp time, and emerge somewhere else. Maybe in a distant corner of our own galaxy, maybe billions of light years away, or maybe in a different time altogether. But if there is an entrance, there must be an exit. The mathematics predicts a twin to the black hole, an object that is the exact opposite of the dark monster we know. A white hole. While a black hole allows nothing to escape, a white hole allows nothing to enter. It would be a region of space that spontaneously erupts with light and matter, spewing out everything that fell into its twin on the other side. A cosmic geyser of creation. We have never seen a white hole. They remain purely theoretical. But their absence in our skies might just mean we are looking at them the wrong way. Consider the Big Bang. 13.8 billion years ago, our entire universe exploded out of a single point of infinite density. It was a sudden, massive expansion of matter and energy from a singularity. Does that sound familiar? Some physicists have dared to ask the ultimate question. What if the Big Bang was actually a white hole? What if our universe is the other side of a supermassive black hole in a parent universe? Imagine a star collapsing in a higher dimension. It falls into a black hole, crushing down into a singularity. But instead of ending, it punches through the fabric of its reality and expands outwards on the other side, inflating a bubble of new space-time. That bubble is us. This theory, called cosmological natural selection, suggests that black holes are the reproductive organs of the cosmos. They are the seeds of new universes. If this is true, then we are living inside a black hole right now. The edge of our observable universe is not a wall. It is the event horizon seen from the inside. And every time a black hole forms in our galaxy, a new baby universe is born within it, hidden from our view, expanding into its own dimension, creating its own stars, and perhaps its own life. The monster, then, is not a villain. It is a mother. The evidence extends beyond the realm of destruction into the realm of infinite creation. It suggests that reality is not a single, lonely bubble, but a frothing foam of universes endlessly birthing each other in the dark. But even if universes are born, they must also die. And the final fate of the black hole reveals a destiny for our cosmos that is colder and lonelier than anything we have yet imagined. But let us return from the dream of other universes to the cold reality of our own. Because no matter how many baby universes are born, this universe, our home, is dying, and the monsters will be the last witnesses to its final breath. To understand the true dominance of black holes, we must look forward, far forward, beyond the life of the Earth, beyond the life of the Sun, into the era of deep time. Cosmologists divide the timeline of the universe into eras. We are currently living in the stelliferous era, the age of stars. It is a time of light, warmth, and energy, but this is a fleeting summer, a brief flash in an eternity of darkness. One by one, the stars will run out of fuel. The massive blue giants will explode first. Then the sun-like yellow stars will swell and fade. Finally, the small red dwarfs, the longest-lived stars, will flicker and die. The galaxies will go dark. The nebulas will dissipate. The universe will become a graveyard of cold rocks, neutron stars, and white dwarfs. But amidst this cosmic winter, the black holes will remain. They will be the kings of the dead universe. Welcome to the black hole era. This era will begin roughly 100 trillion years from now. In this dark future, black holes will wander through the silent galaxy, sweeping up the remaining debris. With no stars to outshine them, they will be the undisputed masters of gravity. Over timescales that are impossible to comprehend, years numbered with a 1 followed by nearly 100 zeros, the orbits of dead stars will decay. Anything that is not ejected from the galaxy will eventually be swallowed. The supermassive black holes at the centers of galaxies will grow fatter and lonelier, consuming everything in their reach until there is nothing left to eat. Imagine a universe of absolute darkness. No light, no warmth, just massive silent spheres of gravity drifting through an expanding void. But even these immortals are not truly immortal. As we learned from Stephen Hawking, they are leaking. Very, very slowly, they are radiating their mass away into the cold vacuum. In this distant epoch, the only light in the entire universe will be the faint, ghostly glow of Hawking radiation coming from the slowly dying black holes. They will act as the last heaters, the last batteries of a dying cosmos, but the process is agonizingly slow. For a black hole the mass of our sun to evaporate completely, it takes a number of years so large that if you wrote it down, the zeros would fill a library. For the supermassive monsters like Ton 618, it will take a Google years. But eventually the clock will run out. As a black hole gets smaller, it gets hotter. It radiates faster. In its final moments, after watching the universe age for an eternity, the black hole will release all its remaining energy in a violent explosion. A final flash of light in the dark. One by one, across the endless void, the black holes will detonate and vanish. The monsters will die. And when the last black hole evaporates, the universe will enter its final state, the dark era, a sea of photons and particles cooling down toward absolute zero, drifting apart forever. This vision of the future is terrifying. It suggests that chaos and darkness are the ultimate destiny of nature. But wait. Before we surrender to the nihilism of the end, we must look at one final piece of evidence, a clue that suggests that this heat death might not be the end of the story, but merely the clearing of the board for a new game. The monsters might have one last trick up their sleeves. Is the darkness truly the end? For a long time, the standard answer was yes. We believed the universe was a one-shot deal, a single explosion, followed by a long, slow fade into oblivion. But recently, a Nobel Prize-winning mathematical physicist named Sir Roger Penrose has stepped forward with a radical new idea. He suggests that the monsters we fear, the black holes, are actually the cleaners of the cosmos, preparing the stage for the next act. To understand this, we have to ask a strange question. How does the universe know how big it is? Right now, you know how big a meter is because you have atoms to compare it to. You have a ruler made of matter. But in the far distant future, after the black holes have evaporated, there will be no matter left. No atoms, no protons, no electrons, only photons, particles of light drifting in the void. Here is the magic trick. Photons have no mass, and because they have no mass, they do not experience time. For a particle of light, the moment it is born and the moment it hits something 1 billion years later are the same moment. Penrose argues that in a universe filled only with light, the concept of size disappears. If you have no clock and no ruler, huge and tiny become mathematically identical. The cold, empty, infinite end of the universe looks exactly, mathematically, like the hot, dense, infinite beginning of the Big Bang. The end is the beginning. Penrose calls this conformal cyclic cosmology. He suggests that our Big Bang was not the start of everything. It was merely the start of our aeon. Before us there was another universe, and before that, another. An infinite chain of universes rising like a phoenix from the ashes of their predecessors. So, what is the role of the black holes in this infinite cycle? They are the entropy scrubbers. The universe is like a messy room that gets more cluttered over time. This clutter is called entropy. For a new Big Bang to happen, the universe needs to be reset. It needs to be smooth again. Black holes spend billions of years swallowing the clutter. They lock away the chaos of stars and planets, and when they finally evaporate through Hawking radiation, they return that energy to the universe in a form that is pure, uniform radiation. They are not destroying the universe. They are washing it. They are erasing the scars of the past so that the future can be born clean. But is this just a beautiful story? Or is there proof? This is where the monsters speak to us from beyond the grave. If a previous universe existed, it would have had its own supermassive black holes. When those ancient giants collided, they would have sent out gravitational waves so powerful that they might have left an imprint on the Big Bang itself. Penrose and his team have looked at the cosmic microwave background, the afterglow of our creation, and they claim to have found rings. Subtle. Circular patterns of energy that shouldn't be there. He calls them Hawking points. If he is right, these rings are the ghosts of black holes from a dead universe that existed before ours. They are the echoes of a previous reality, shouting across the barrier of time. This changes everything. It means we are not living in a lonely, dying container. We are part of an eternal heartbeat. an endless rhythm of expansion and contraction, death and rebirth. The monster, it turns out, is the midwife of eternity. But this grand perspective leaves us with one final haunting question. If the universe is eternal and the black holes are the engines of rebirth, where do we fit in? What is the meaning of a human life lasting less than a century in the face of such overwhelming infinity? To answer this, we must return to Earth. We must look into the eyes of the monster one last time, not with fear, but with recognition. We are now nearing the end of our journey. We have traveled from the crushing depths of the singularity to the birth of new universes. We have seen that black holes are the destroyers, the creators, and perhaps the recyclers of reality. But amidst this grand machinery of gravity and time, there is one component we have overlooked, the most complex object in the known universe: you. It is easy to look at a black hole with its mass of billions of suns and feel insignificant. It is easy to feel that we are nothing more than biological dust on a rock orbiting a mediocre star in the suburbs of a galaxy. But this is a mistake, because without the monsters, you would not be here. Remember the supernova in the beginning? The dying giant that collapsed to form a black hole? In its final breath, before it vanished into the dark, it forged the heavy elements. It created carbon, oxygen, nitrogen, iron. It exploded those elements out into the galaxy. They drifted for eons, mixing with gas, cooling down, and eventually collapsing again to form a new yellow star, our sun. And the debris around that sun formed a blue planet, and the iron from that dead star found its way into the soil, into the plants, and finally into your blood. Hold out your hand. Look at your veins. The iron running through your body right now, the iron that carries oxygen to your brain and allows you to think these thoughts, was forged in the core of a star that died to become a black hole. You are not separate from the monsters. You are their children. You are the nuclear ash of a cosmic suicide, woken up and given a name. But your connection goes deeper than just chemistry. It goes to the very nature of reality itself. Quantum mechanics teaches us that the universe behaves differently when it is observed. An electron does not have a definite position until it is measured. The act of looking changes the outcome. If this is true, then a universe without observers is just a blur of probabilities, a ghost town of math. By opening your eyes, by building telescopes, by looking up at the night sky and asking, "What is that?" You're doing something magical. You're collapsing the wave function. You are rendering the universe into reality. Perhaps the black holes are the engines of the cosmos, but we are the audience, and without an audience, the show has no meaning. We are the universe experiencing itself. We are the way the cosmos knows it exists. And we are incredibly lucky to be here right now. We are living in a privileged moment in time. Right now, the universe is bright. The galaxies are close enough to see. The black holes are feeding and active. But in the distant future, billions of years from now, the expansion of the universe will push the other galaxies away faster than the speed of light. They will disappear from our view forever. Future civilizations, if they arise on distant worlds, will look up and see only their own galaxy. They will see a dark, empty void. They will conclude that they are alone in the universe. They will never know about the Big Bang. They will never know about the cosmic web. The truth of cosmology will be lost to them forever. But not to us. We have opened our eyes in the golden age of astronomy. We are the only ones who will ever know the full story. We stand on this tiny rock, armed with nothing but mathematics and curiosity, and we have managed to weigh the ghosts. We have managed to take a picture of the invisible. This suggests that while we are small in size, we are infinite in potential. The gravity of a black hole can crush a star, but it cannot crush a question. The human mind is the only thing in the universe capable of holding the monster inside it without dying. We have faced the darkness. Now it is time to return home. It is time to close the book and drift back to the safety of the earth. But we return changed. We are no longer afraid of the dark because we know what is hiding there. So, tonight, as you lie in the safety of your room, close your eyes and let your mind drift back up one last time, past the roof, past the clouds, past the quiet orbit of the moon. Look out into the great vast darkness. We began this journey fearing the silence. We began by looking for monsters in the dark, and we found them. We found gravity so strong it breaks the sky. We found time stopping on the edge of forever. We found engines that destroy stars and perhaps birth new universes. But we also found something else. We found connection. We learned that the black holes are not separate from us. They are the weavers of the cosmic web. They hold the galaxies together. They seeded the clouds that formed our sun. They forged the iron in our blood. Without their terrifying power, the universe would be a cold, shapeless mist. There would be no stars, no planets, no us. The monster is not a villain. It is the anchor. Gravity, the force that crushes stars, is the same force that keeps your feet on the ground. It is the same force that keeps the earth circling the warmth of the sun. It is the invisible embrace that holds reality together. The universe is violent, yes. It is chaotic. It is incomprehensibly large. But it is not cruel. It is a system of perfect balance, life and death, light and dark, expansion and collapse. We are small, fleeting sparks in this eternal machine. But we are the sparks that can dream. We are the part of the universe that has woken up to look at itself in the mirror. And even though we cannot see what lies inside the singularity, even though we cannot know for sure what came before the Big Bang, we can rest in the knowledge that we belong here. We are made of stardust, drifting through the infinite, held safe in the arms of gravity. The mysteries will remain. The great attractor is still pulling us. The event horizons are still hiding their secrets. The dark energy is still pushing the galaxies apart. But these are not puzzles we need to solve tonight. They have waited for billions of years. They can wait a little longer. For now, the stars are burning. The planets are turning. The cosmic ocean is calm. The journey does not end here. The universe is vast. The mysteries are endless. But for tonight, our voyage is done. Drift on the waves of space-time. Let the gravity of sleep pull you in. You are safe. You are home. Good night.